All right, welcome back, everyone. Welcome back from the week of the Bluefield Coal Show. Thought it went very well. Thought we were very well represented out there, both in terms of students and alumni. The booth was well visited. We gave out a lot of our swag, to people that told me that they saw a lot of Bluefield State shirts and hats around in the crowd. So that's great. We also, our interview that was posted on the Bluefield State or the Bluefield Coal and Mining Show's Facebook page received so far the most interactions from any of the videos posted on that page. So if you are old enough to have Facebook, please go there, the Bluefield Coal and Mining Show's Facebook page, and like, comment, share, whatever. Mine and Isabella's interview there, and help us get the word out about the program. So that's probably, I don't know, enough introduction there. Let's jump into our next topic, and I chose it because we just got done doing shield design stuff, and I thought we would now jump into a little bit of the Longwall Gateroad supports and what you're likely to see out there, and what I saw during my time at NIOSH, because you can see the source here is myself and my colleagues Burke Tulu and S.E. Esterhuizen. From back in, we finished this up about in 2015, ended up getting the journal article published 2017. So basically the time period that you're going to be looking through here is 2010 to 2015. So not that long ago, still pretty relevant. And we're just going to discuss the overview of current practices, right? So this isn't something that I was ever taught in college. Okay. I didn't know about this. In fact, I don't know what existed at that time until we went out there and actually did this study and put it out there. There has been some work done on this in the past, but one of the best tools you can have, especially if you're in a new area, is knowing what your neighbor's doing, and that's not always necessarily easy to determine. But works like this can also help you as well. To give you an idea of just what's going on across the country, right? So to start off, I was trying to look at has what we've done over these 10 years, has it helped? Has it reduced roof falls, accidents, and injuries? And so to look at that, I just grabbed the reportable roof fall rates across the country, and you can see there's been a significant downward trend. You'll notice a big gap actually between 2011 and 2012. A big part of that is where MSHA redefined what constituted an area of the mine where you would need to report a roof fall. So there's some areas, that are never travel, they're not travel ways, that are not, accessed for pretty much any reason. And those don't have to be reported. So that changed that year, and so you see a big drop, and then it sort of, just kind of flattened out there through the rest of that, period through 2015. The injury rate also went down, right? Had a downward trend, and then kind of sort of leveled out there again at the end of those couple of years. But that was the range we were looking at the time. But what I wanted to know was not just if a roof fall was reportable, but I wanted to know if a roof fall resulted in a blockage of the gate road, so a tailgate blockage, or a fall on the stage loader or something like that, or a fall that occurred in other areas of the gate road, but places where mine workers would typically be traveling or working in, right? That's the ones I really wanted to focus on, because those are the ones that really matter when we're talking about gate road support, right? And so you see a huge sort of downward trend in tailgate falls, tailgate blockages towards 2010, and then it decreases again after a couple more years. So we've gotten really good at stopping these tailgate blockages. Primarily, it became a major concern after the upper big branch explosion, right? That that not having two means of egress off the face was not acceptable. And so, but you do still see a few of these blockages. Those were primarily mines out in Utah, where they just get such tremendous convergence in the entries that you can't get off that tailgate side. So it does still happen, but it's been minimized now. As far as headgate falls, these have always been historically fairly low, because you can't produce anything if you got to fall on the headgate, right? It's fall on the belt, it's down the stage loader, something like that, and so those have traditionally been held as low as possible. And then finally, this sort of like other falls, it kind of went into the same trends as the headgate side. So what we see here, there is a little bit of a discrepancy here. So the way I retrieved this data is I actually manually read the narratives that were written in the reports for all of these cases. So there is some ambiguity there in where some of these cases occurred. So there is some amount of error in this, but I think it's relatively low, and I still think that this gives a good picture of the roof fall rates that have occurred in this country in that time frame. So from there we jump into summary statistics for general mine data. So kind of like those charts we saw in the coal age longwall census, I did these for all of our cases, right? So in this paper, which I will publish, put on the website as well for you to read if you'd like. The way I did this was we went to 11 longwall mines, and so we got as many cases from there as we could, because some mines would have more than one different support layout in different areas of the mine. So we went to 11 longwall mines, and then I gathered previous reports in that same time frame for other mines that other researchers had gone to, and I took as much data from there as I possibly could too. And that's how I ended up with the 25 case histories from 21 different mines that went into this paper. And at that time, the average or the range of depth of cover ranged from 400 feet to 3,000 feet. Yes, we were still mining 3,000 feet of cover at that time out in Utah. We're not anymore currently, but it could happen again. So at that time, they were mining that. And mining heights ranged from 6 to 11 feet, and then 16 to 22 foot wide entries. So you see the averages come out to be about 1,300 feet of cover, 8.25 feet mining height, and an entry width of 19 feet. Oh, and the number of entries too. You see it ranges from 2, like the yield pillar layouts out in Utah. The average is 3, which is what you see in most mines, with a maximum of 4, which at the time was only in one mine, so I think a lot of you might know where that is. So it's in here too. As for the summary statistics for the panel layout, you'll see on the right side that an N value here. And so I didn't have this data for all of the mines in the database, right? So the N value represents the number of mines who had this particular bit of data in the report that I could pull from. And so our gate road widths range from 67 feet to 290 feet. And so what I mean by gate road width is, it's the entire distance across the Longwall Gateroad, like we've seen in some of the panel layouts that we've looked at. So it's the entire distance. This gives you an idea of how much pillars support is left in the ground in between those panels, without knowing the the complete details of the pillar dimensions. It just gives you an idea. And so you see 67 feet on the left. Of course, that's a about a 30-foot, 47, yeah, about a 30-foot or a foot rib to rib yield pillar, right, out in Utah. And of course, the max, at that time was 290 feet, which would be a deep cover mine that had large abutment pillars in it. Panel widths range from 600 to 1,500 feet, with an average of 1,000. So we're continuously working towards wider and wider faces. But like I said, out in Utah, especially in those depths reaching 3,000 feet, it's difficult to mine panels that are wider than about 500 feet, or in this case, about 600 feet. Okay. I think the average, if we looked at the Longwall census today, I'm betting you the average face width is 1,200 feet or a little bit beyond, would be my guess. Panel lengths, 5,000 to 22,000 feet. You'll see those short panels over there on the left side, the 5,000 foot panels. Again, those are the Utah longwall mines whose, the geology that they're working in, they're Horst and Graben faults that have very large amounts of throw, say 100 feet or more. Okay, and so the mines themselves have to be within these boundaries. Okay, and that limits how long your panels can be. So you see a lot of shorter panels out there for that reason. And then what you can do, or some of the mines have done, is then once they reach that fault, they'll actually put a slope in, or ramp, however you want to think of it, across that fault, just like you would if you were driving a slope from the outside, except it may be up instead of down, and just access the seam that way. Drive back up, throw in another set of mains, put in another set of panels, and continue. Longest panel at that time, 22,000 feet. Average was 10. I bet the average is now closer to about 12 or so. Barrier pillar widths. Okay, so barrier widths between districts, or at the mouth of the panel, these ranged from 220 feet to 750 feet. Lower amounts would mean lower stress or lower cover, right? Higher or wider barriers for deeper cover mines. And that average being about 440 feet or so. Before we get into the details about the actual support itself, there is an equation you need to know, the reinforcement density index, okay? And for standard units, there's a conversion factor of 14.5. And then you basically just multiply the length of the bolt by the number of the bolts per row, right? That's typically 4, sometimes 6, sometimes 5 even. But number of bolts per row. Then you multiply that by the ultimate strength, or the ultimate capacity of the bolt. And that value is in kips, so it's in thousands of pounds. That's one of my least favorite units, but structural engineers like it, so that's, I guess, why we're doing it for roof bolts. And then you divide that by the spacing between rows and the width of the entry, right? So what you've kind of calculated here is sort of like how much one bolt is doing, right? It's the length of the times based on that, sort of like that tributary area, right, that the bolt's working in. And then the index is calculated like that. Summary statistics for primary support in the headgate. Bolt lengths range from 5 feet to 9 feet in length, with an average of 6.4. Some were number 6 through number 8 rebar, so actually a 1-inch bar. This is prior to the wider adoption, so the .804 rebar. And so most of the mines were using 7/8 bolts, right? It's just as the average. Or they were using 3/4 bolts, and they were probably the mines that are using that 6 per row, right? So with bigger bolts, you can use less per row. Smaller bolts, you would have to use more per row, and that's where you get this sort of average of 7/8 and 4.5 bolts a row. Okay. Row spacings was 4 to 5 feet. Occasionally in a bad area, you'd see that spacing tighten down to 3.5 feet or maybe even 3 feet. But I used the sort of average of what the conditions were and what they were using. So 4 to 5 feet, right? And then, of course, with that RDI calculation that we talked about on the previous slide, I came up with RDI's reinforcement density indices of 57 psi feet to 100 and basically 130 psi feet. And so that gives you an idea of how much support is in the roof. And it's, like I said, it's based on bolt length, the number of bolts, the strength of the bolts, and the spacing, okay, to get these numbers. The secondary support, you can do the same thing, and I did. So most mines were using secondary support. You see the N value here is kind of low, and that's because most of those numbers were coming from the mines we had recently visited, not some of those from the previous reports. And those bolts ranged from 8 to 12 feet in length, okay, and were either 0.6 or 0.7. They did because you see the mean bolt length is 11 feet. That's a lot closer to 12 than it is to 8. That means the length of the bolts were skewed towards the long end. So there's more 12s than there were 8s, for sure. And I would say now, if you went into there now, you're going to see even more. The maximum is definitely going to be 16 somewhere. Somebody's probably using a 16. And like I said, the diameter, you only have the two choices, 0.6, 0.7. And then number of per row, you can go from 1 to 4. 1, in this case, being sort of used as like a primary support in the Pittsburgh seam, where you'd have the 2 bolts installed on the outside, then 1 cable in the center. That's where this 1 refers to. So you could also kind of count that as maybe being primary support as well, but put it in as secondary. Up to maximum of 4. In areas where you're at an unfavorable horizontal stress orientation, Pittsburgh seam, I've seen it myself, for 0.7 tensionable cables per row. Yeah. But the average was 3, and that row spacing average was 6 feet. Somewhere between 4 and 10, or 4 and 8, right? That's sort of the range that you're looking at. It's either every row or every other row, typically, when you're installing cables. And you can also calculate the RDI for this as well, and then calculate a combined RDI by adding them together, right? And so this ranged from 51 psi feet to 305, and so combined, you're looking at a range of 130 to 380. That's not 400%, but it's a little bit more than 300%, right? So that's a pretty significant range on, what those supports are like in this country. As for standing supports, you're going to see several different things out there. First of all, wood cribs, which are going away rapidly. Probably, I would say. You'll see in here that there's even less mines now that are using them. And also could have an engineered wood crib, which is maybe more popular because they are very strong, and it's still a wood product. It has a very large range of deformation. You can really squeeze these things a lot, and they don't really fail. They just get stronger over time. They strain harden. So you're probably more likely to see one of those, an engineered wood crib of some kind. To my knowledge, there's not a mine that's using wood cribs entirely in the gate road. Since federal number 2 closed, there could be one that's popped up and I'm not aware of, but you might see it out there. Prop setters and cluster props. Sometimes these can be used, especially if you have a mine that's not that deep and has a decent roof. You might be able to get by with these, right? And they're a very strong prop too. They do have a significant range of compression that you can go through, and allows that prop to to deform a bit. There is a current issue with these though, that there's been issues getting the wood, the poplar trees for these again. This has happened before. It's the main reason you don't see wood in the western United States. They just don't get it. They just, they can't get it. Might as well just use, cans and pumpables, which is what you're going to see on the next slide. Cans and pumpables, right? So non-wood support, the can on the left, this steel sort of liner, and then it's filled with a cementitious type grout. And then that can then just sort of folds, right? And almost crushes like a pop can, but it just folds over and over and over on itself and allows a tremendous amount of deformation before it fails. It's an extremely good support. If you need a lot of capacity and you're going to have a lot of deformation, it's a good call. Pumpable cribs, they're great. They're the easiest to install. They're usually the most expensive. Well, cans are pretty pricey too, but usually the most expensive, but they're the easiest and fastest to install. Sometimes it's, speed's worth paying for, right? You're making money on how many tons you can put on the ground, outside, on the train, in the customer stockpile. That's where you're getting paid, not off of what's in the ground. So speed's important. So, and it's also a lot easier on the labor force. So when I did this, I figured out the distribution of what support types were in each mine. And some of the mines, they were using multiple supports for a given gate road. I think that was about 16% of the mines. So not that many, but a few were. But in this case, there was 37% were using cans. Several of the mines were out in Utah, that sort of thing. 23% of the mines at the time using wood cribs. Okay, 23. That's still a significant amount, right? Engineered cribs were really low, 6%. Yielding props at 14%. Pumpable cribs came in at 14%. And you'll see here, cable bolt / truss, 6%. At the time, there were still cribless tailgates. This idea of where you could cable, use cables in the tailgate of these mines out in Utah that had really, really strong roof. And it turns out it did work. So what would happen was it would hang up for a really long time, and then it would fall basically up to the shield line or close to it. And what's kind of happening was you were breakering that fall with the cables, right? Just like you would on a pillar line if you had breaker cables, right? It's kind of the same concept there. You can breaker a fall with a cable bolt, or more than one, but by putting them in, you can breaker a fall with it. And that's kind of what this was doing. And it was repeating itself sort of based on this, like the periodic waiting period, right? It's kind of the same concept. You'd mine, it would hang, and then eventually it would fall, right? And that's kind of what it would do. But they did exist then. They've really fallen kind of out of favor. I don't think anyone's doing them now, but it's possible, but I doubt it. And so because of that, I wanted to see, because some of those mines closed in the meantime, what did it look like for the mines that were still active in 2015? And here's where I'm saying you're seeing the significant decrease in wood cribs. It dropped to 12%. In this case, that's probably just the one mine, Federal 2, right? 44% can supports. The mines out in Utah didn't close, they're still open. Engineered cribs at 8%. The mine that was using those still was. And at that time, they still had a cribless tailgate at one mine. It could still be there. It could. But I don't think. Yielding props at one mine, and then the rest had pumpable cribs. And so the summary statistics for tailgate support for this, okay. I'm looking at the number of rows in the tailgate, which range from 1 to 2, with a mean of 1.9. So it's almost like always had 2 rows, right, in the tailgate. And that all mines had data for this data point. But what you don't see is that many that have a data point for number of rows in the number 2 entry. You only see 10 mines, right? Well, the number 2 entry, didn't, get a lot of, emphasis put on it until, like I said, Upper Big Branch, right after that explosion. It was decided that you should have enough support in the number 2 entry that it can stay open from start to finish, right? So that you can effectively get air down through that opening. And that's when you see number of rows in 2 going from, 1 and now almost 2 rows in number 2 all the time, right? Because that average is 1.7. And then the summary statistics for the tailgate, we do a little bit of a different calculation. We're doing the standing support density instead of the roof density index. It's similar, but not quite the same. You'll see the units in this case are just pressure, PSI or MPa, right? And the best way to sort of think about this and to calculate this is you're looking at the amount of tons of standing support capacity that you're putting in that entry per foot of gate road. Then you take that value and you take into account the width of the entry, right, which is in feet. You could then calculate this pressure that you're installing in this gate road, and that's how we kind of looked at it. And for the tailgate itself, it ranged from 7.2 to 26. Pretty decent range, but you could tell that typically you're gonna have more support in weaker roof and floor, right? That average ended up being 18.2. And then in the number 2 entry, for the min and the mean, you see they're actually the same value, but there's an outlier in this case where they actually put twice as much support in that number 2 entry. I don't know which mine this was, but I'm betting that it was pretty gassy and that, there was obvious concern. It was probably immediately after Upper Big Branch, and so they put a whole lot of support in that number 2 entry, 50 PSI. So with that, I'm going to close it out, and I'm going to be putting this, of course, on YouTube like I do all of my lectures. You can catch me there at Dr. of Rocks. I'll also be, for the students, be putting PDF copies of the presentations there as well. That way, if you want to just look back, do an equation or something like that, and don't want to have to see my, my happy, shining face and listen to me, then you can do it that way. That'll be going on too. And then I'm also going to be getting ready to do a sort of a presentation on the outlook for the program, rather. And because I have some things that I want to discuss about what our near-term and long-term future is going to look like and what I hope to be able to accomplish here. So with that, see you next time.